the last video, we took a look at being able to find derivatives of functions by using the product rule. In these two examples, we're going to be taking a look at an extension by utilizing the quotient rule. All right, so we have this function, f of x equals 9x minus 1 over x minus 1. And we want to find the derivative of that function at any point. Recall that if we wanted to find the derivative of two functions being divided, that was equal to, and we call those f and g, that was equal to f prime g minus fg prime over g squared. All right, and so in this problem, we're going to define f to be the numerator, 9x minus 1. We're going to define g to be the denominator, x minus 1. And the good news is both of these are very easy to find the derivatives of. Now we know the derivative of 9x minus 1 is just 9. The derivative of x minus 1 is 1. And so what we can do is we can now substitute it back into this formula and then simplify. All right, so f prime of x, right? So we're going to do f prime g minus fg prime, right? So that's going to be 9 times x minus 1, so that's f prime g, minus fg prime, so 9x minus 1, times 1, so that's fg prime. And then we're going to divide that by g squared, which is x minus 1 squared. Right, so this is our g squared in the formula. We're going to distribute the numerator and then collect some like terms. All right, so if we distribute the numerator, 9x minus 9. Now be careful, all right? We have a negative, and we also have a 1 that we're distributing. All right, so it might be helpful for us to just move that 1 in front. So that's going to be negative 9x plus 1 divided by x minus 1 squared. And then finally, we notice in the numerator we have opposites of 9x, so they cancel out. Negative 9 plus 1 is going to give us negative 8x. So two ways to write this derivative. Negative 8 over x minus 1 squared, or the opposite of 8 over the quantity x minus 1 squared. All right, so I don't think it really matters in my math lab which one you get, all right, or which one you enter, excuse me. However, just make sure that you understand that those two quantities or those two solutions do mean the same thing. Another example, this time with a quadratic. Right? So this time we have 7x squared plus 3, x squared plus 1. And we're going to find our derivative again by using our quotient rule. Just to remind you, it's f prime g minus fg prime divided by g squared. And so let's define f to be the numerator once again. So f is going to be 7x squared plus 3. And then g is going to be equal to the denominator, x squared plus 1. And so f prime, we're going to use our power rule. 7 times 2 is 14. 2 minus 1 is x. G prime, derivative of x squared. 2 times 1 is 2. 2 minus 1 is 1. And we don't write 2x to the first, we just write it as 2x. Derivative of this 3 and this 1 respectively are both 0. So now we can find the derivative by using our quotient rule. And so h prime at x is going to be equal to f prime g, so that's 14x times x squared plus 1, minus fg prime. Now I'm just going to swing g prime in front to make it easier to distribute. So that's going to be 2x times 7x squared plus 3. And then finally, we're going to divide that by g squared. Remember, g is x squared plus 1, so that's going to be x squared plus 1 squared. We're going to simplify the numerator. Let's see if I can undo that. Oh, I'm going to have to do it again, unfortunately. So hang tight for a minute while I rewrite this. Not sure what happened. Computer glitch. So that's going to be equal to 14x f prime g, x squared plus 1, minus, remember we swing that g in front, 2x, 7x squared plus 3, and then we're going to divide it by x squared plus 1 squared. All right, so hopefully it doesn't move again. Okay, there we go. Now, we do have to distribute in the numerator, so we're going to simplify this. So distributing 14x, we get 14x cubed plus 14x. Distributing the negative 2x, we get minus 14x cubed minus 6x. And in the denominator, we still have x squared plus 1 squared. And so ultimately, what does that turn into? Fortunately, we get this to cancel out. And then we have common terms of 14 and negative 6x. That's going to be 8x. So one solution is positive 8x over x squared plus 1 squared. All right. So that's our solution. All right. Now, to think about this, there are times, and this isn't one of them, right, where we can actually turn a quotient rule into a product rule. And sometimes it's easier to think of it like that. And I want to illustrate that we can get the same answer by turning this problem as a product rule. Okay, so let me go down here. You might need a little bit more space. And do keep in mind the answer. It was 8x over x squared plus 1 squared. All right. Now, our original function was 7x squared plus 3. So our function h was 7x squared plus 3 divided by x squared plus 1. Right? That was our original function. Right? Just to make sure I got it. What if we thought of it like this? Remember that trick that we can turn a negative exponent, or we could turn a denominator into a negative exponent? So what if we thought of it like 7x squared plus 3 times x squared plus 1 to the negative 1 power? And it would turn it into a product rule. And you might be thinking, well, why would I want to do that? I mean, I have a quotient rule, and it works really nicely. All right, but there are going to be times where this does help you. All right, just this isn't one of them, but I want to illustrate that you can get the same solution. Let's define little f to be 7x squared plus 3. Let's define little g to be, now be careful, this is going to be x squared plus 1 to the minus 1. All right, and unfortunately, we don't know something called a chain rule at this point to be able to find the derivative of this g. So we're kind of stuck at this point because we don't know what this derivative is. It's 1 over x squared plus 1, and we don't know what that derivative is. Okay, so what I'll do is when we learn the chain rule, and that's going to be in section 3.5, we'll go back through and I'll make a video as to how to use the chain rule combined with the product rule to get the same solution that we did here. But for right now, we can't do that, unfortunately. But we can just use the quotient rule and get a really nice solution for this easily. All right, so hopefully this helps you all to be able to use the product rule, to use the quotient rule, to be able to find derivatives of these a little bit more complex functions.